Hello everyone, my name is Qiang Zhang. I am going to introduce PhoneGap in a simple manner so that you'll have a rough idea of why you need PhoneGap and what PhoneGap can do for you. Nowadays, the mobile application market is expanding exponentially. As a developer, you really want to develop some mobile apps to make a fortune. However, language barriers may draw you back since you don't know Objective-C, Android SDK, or the Microsoft .NET framework. More importantly, you don't have the time to learn them. So you may wonder, can I develop some mobile app technologies that I'm familiar with without using that crazy stuff? Yes, you can, and the answer is using PhoneGap. First things first, what exactly can we do with PhoneGap? PhoneGap, which is currently named Apache Cordova, is a framework that builds cross-platform mobile applications. It uses popular web technologies like HTML, CSS, and JavaScript to develop mobile apps on iOS, Android, and other mobile platforms. Building a mobile application with PhoneGap is as simple as building a web application. More powerfully, the PhoneGap app can access native mobile functionalities such as the camera, contacts, and GPS. Theoretically, a complete PhoneGap app consists of the native part and the web part. In most situations, we only need to develop our business logic using web technologies, without bothering with any native code. So how does PhoneGap work? PhoneGap wraps a WebKit component for different mobile platforms to run the web code, and adds JavaScript interfaces so that the native functionalities can be invoked in the web code. An app running inside the native container, rendering web pages, and also accessing device capabilities is called a hybrid app. PhoneGap is a hybrid app platform. Why choose PhoneGap over other similar products? Listen to these numbers about PhoneGap. By 2011, there were over 10,000 users and 23,000 PhoneGap apps deployed on the App Store. Over 3,000 apps are built using PhoneGap every day. Besides these amazing numbers, it costs no money to use it. PhoneGap has been a popular lightweight solution for mobile applications. Also, we can understand the benefits of using web technologies if we use PhoneGap. For example, reducing learning time, the cross-platform feature, and using existing JavaScript libraries and web services. We can even do more with cutting-edge web technologies such as HTML5 and CSS3. To access native functionalities, PhoneGap exposes simple JavaScript interfaces that can be extended with numerous PhoneGap plugins without writing a single line of native code. In this section, I have introduced what PhoneGap is and the reason to choose it as your mobile development platform. I will go through some PhoneGap limitations and barriers in the next section to help you understand PhoneGap completely. In the previous section, we simply discussed what PhoneGap is and what are the benefits of using PhoneGap for mobile application development. Nothing's perfect. Although PhoneGap can cover over 90% of mobile application requirements, it also has its limitations. This section will give you a full understanding of PhoneGap so that you can decide whether PhoneGap is the solution for your business. First, native apps always feel like native apps since they have native UI components, while a PhoneGap app is simply a web page which has a big distance from the native UI in terms of look and feel. Fortunately, CSS3 opens the door to this fancy UI. Look at the UI components using CSS3. You can't tell if they're not native. Also, most mobile web application frameworks provide various UI themes. PhoneGap app UI is no worse than a native app. Aside from the UI, PhoneGap currently says no to hardcore 3D applications. If you want to develop a 3D game, PhoneGap is not a good choice. This results in some amount of debugging work on specific devices after development. For example, CSS scrolling is only supported after 2.3 for Android and 5.0 for iOS. This video course will cover most of the gaps for your development. If you have ever written web pages, PhoneGap is your dream platform to develop mobile applications. But the development of PhoneGap apps is not fully equal to that of web pages and web applications. Firstly, PhoneGap apps are stored locally on the device, while web pages and web applications are hosted on a web server usually. This means there's nearly no latency to load up stored web pages and assets for PhoneGap applications. Besides, PhoneGap apps can run offline. Internet connection is only an option for PhoneGap apps like native apps. Secondly, PhoneGap apps can access device capabilities through JavaScript interfaces, like the accelerometer, camera, compass, etc. In this course, we're going to cover the following contents. PhoneGap app development process will include how to install PhoneGap and develop and publish your app. Development preparation contains a tutorial of tools that will help you in app development. It will also introduce some fancy CSS and cool HTML skills. A good practice for JavaScript code is more important than ever. Also, introduce some helpful application frameworks. And how to import PhoneGap plugins to make your app more powerful. And how to connect your app to remote servers. And finally, I will demonstrate a complete example. In this section, we covered some limitations of PhoneGap and how this course is going to help with your development. Now you should have a full picture of PhoneGap and should be able to decide whether a mobile application can be written in PhoneGap or not. Please take a look at the related links, which are very useful for your learning. In the next chapter, we will install PhoneGap and start to use it. After going through the last video, you should have a full picture of PhoneGap and PhoneGap applications. Now we're going to install PhoneGap and start using it. This section will state where to download PhoneGap, how to create a PhoneGap project, the PhoneGap project structure, and the commands. PhoneGap is installed through npm, which is a Node.js package manager. This means that we need to install Node.js and npm first. We will introduce Node.js and npm soon in the upcoming videos. For now, we keep it simple. To install Node.js and npm, open your browser, go to nodejs.org, and then click the Install button. The installation procedure is very straightforward and will install both Node.js and npm. After Node.js has been installed, open a terminal and run the command node-v. If Node.js has been installed successfully, you will see the version of your Node.js package. PhoneGap requires Node.js with a version higher than 0.9.9. Then we need to install PhoneGap or Cordova. You can find detailed installation documentation at phonegap.com/install. In the terminal, run the command sudo npm install-g Cordova. This will install the latest PhoneGap distribution on your machine. Once the installation is finished, we need to check if our system meets the minimum requirement for different mobile platforms, for example Xcode for iOS, Android SDK for Android, and so on. You can find the steps to set up your environment on the PhoneGap platform guide page. The next video will cover it for iOS and Android. Now we are going to create a PhoneGap project. Open a terminal, create a project folder, and go into the folder. The command Cordova create will take three parameters: your project folder path, your project package name, and your application name. The folder path is the location of the folder we created, which is the current folder. The package name is assumed to be com.helloworld, and the application name is Hello World. Now you have created a PhoneGap project and it's ready to be deployed on mobile platforms. I will show you how to deploy it to iOS and Android later. We will develop a Hello World app on the iOS platform first to give a demonstration of PhoneGap app development. We will need the following to go through the demo: a Mac running macOS 10.7 or above, Xcode with version 4.5 or above, and the Xcode command line tool. Basically, if you've gone through the platform guide of PhoneGap for iOS and followed it, you're ready to go. Before we go diving into any exciting app development, let's take a look at the project folder generated by PhoneGap. The www folder is where our HTML, CSS, JavaScript, and other web page related assets files are located for the app. We will spend most of our development time in that folder. The platforms folder is where our native application is generated and stored by PhoneGap per platform. It's empty, and we will add iOS and Android soon. The merges folder is where we specify the assets that are to be deployed on specific platforms. Each platform-specific subdirectory within the merges folder mirrors the directory structure of the www source tree. Whilst the app is compiled, the assets in the www folder will be copied to the native application and replace the existing one copied from the www folder in the top-level folder. The plugins folder is where the PhoneGap plugins used for this project are stored. The added plugins will be automatically compiled to the native application per platform. Now we can create an iOS project. We must first navigate to our PhoneGap folder. Open the terminal app and change the directory to your PhoneGap folder /lib/ios/bin. In this folder, you will be able to see a file called create, which will be used to initialize your iOS projects. It will take three parameters: The first parameter indicates the path to your PhoneGap iOS project. The second parameter is your package name, and the third parameter is the project name. Here we create a Hello World project. The PhoneGap platform has a series of commands that help our developments. In the terminal, type Cordova --help, and you will see a list of commands. Here are some useful commands. The Cordova create command, which we've used before, creates the basic structure of a project. The Cordova platform add remove commands are used for adding or removing mobile platforms. The Cordova plugin add remove commands are used to add or remove a PhoneGap plugin. The Cordova prepare command. This copies web files and plugins to native applications. The Cordova build, emulate and run commands build and run applications on a device or simulator. The Cordova serve command. This creates a web server on the www folder for the purposes of development. We will use these commands in the upcoming videos. In this video, we installed PhoneGap and created our first PhoneGap application. Then, we introduced the structure of a PhoneGap project and basic PhoneGap commands. You should be able to create your PhoneGap application now. In the next video, we will develop our Hello World application and run it on the iOS and Android. In the previous video, we installed PhoneGap and created our first Hello World application. You now probably have a rough idea of the structure of a PhoneGap application. In this video, we're going to write some code to build the application and deploy it to the iOS and Android platform. The PhoneGap platform contains a built-in web server that's very helpful for development. To use the web server, we first need to add a platform. Go to the Hello World project folder we created in the last video and type in the command Cordova platform add iOS. This requires the basic system requirement for using the iOS platform. If you get a failure here, you need to take a look at the PhoneGap platform guide page again, which was introduced in the last video. Once the platform has been added, we can use the Cordova serve command to create a web server. Type in Cordova serve iOS. It will give you a URL where you can see your app. Open the URL in a browser and you will see the default PhoneGap app. Most of our development and debugging will be done with the help of this web server. Coding PhoneGap applications is the same as coding web pages. You need to prepare a code editor and a browser and you're ready to go. Go into the www folder of the project. It contains the default PhoneGap app file. We need to keep the config.xml file in the folder as it's used by the PhoneGap platform. Remove other files so that we have a clear workspace. There are now certain steps we need to perform. Use your code editor to open the empty www folder, which is our workspace. First, we create an index.html file. This will be used as the entry file for the app. In this file, add the doc type that tells which version of HTML we're using. Generally, we use the HTML5 doc type. Complete the basic HTML structure by adding basic HTML tags. You'll need some basic HTML knowledge to achieve this. For all PhoneGap apps, always remember to include the Cordova JavaScript file. We need to link it to the index.html file so that we can use the PhoneGap APIs. Now write some simple HTML code. We add an h1 tag that outputs Hello PhoneGap and a button which outputs Click Me with an ID attribute. We have started the web server previously, so we just need to refresh the page in the browser to see the new content. As in a web page, we could add some CSS to make our app more pretty. You could either use an embedded style tag or link CSS files to the HTML files. Here, we create an index.css file and link it to the index.html file and add some CSS to the elements. We will add some colors, backgrounds and shadows to the page elements and change some properties like width, height and font size. You need to have basic knowledge of CSS to understand these. We will explain CSS3 in upcoming videos. This is what it looks like with the CSS that we just added. JavaScript is at the core of the PhoneGap app. It builds business logic, manipulates the UI, interacts with users, exchanges data and so on. We will talk about JavaScript specifically in upcoming videos. Here we simply add some user interaction code to our button and embed the script in index.html. The first line added an event listener to the device ready event, which will be triggered by the PhoneGap platform when PhoneGap APIs are ready to use. Then the script added an onClick listener to the Hello button. Its onClick callback function pops an alert. Let's see how it works in the browser. So far, we've finished developing our Hello World app. Now we'll deploy it on a mobile platform. Let's deploy it on the iOS platform first. We need to check if our system has met the minimum requirements of the iOS platform. It requires a Mac running macOS 10.7 or above, and you can find that in your About Your Mac menu. Xcode with version 4.5 or above, you can find that in the About Xcode menu. The Xcode command line tool, you can find that in the Xcode preference menu. These details are included in the PhoneGap platform guide page. We need to add iOS platform support by running the Cordova platform add iOS command. You can skip this if you've already added it previously. Then we need to run the Cordova prepare command, which copies files in the www folder to the iOS native application. Here we have two options to build and deploy the app. The first is to use the PhoneGap command introduced in the last video, and the other is to use Xcode. To keep it simple for future courses, we use Xcode. Go to the Platforms folder and then the iOS folder. Open the Xcode project file. Xcode will open the project, and we will deploy it in a simulator. Choose a version of iOS and start the app in a simulator. You can see that the app acts the same as we saw in the browser. Deployment on the Android platform is similar. First, we need to check if our system meets the basic requirements. Unlike developing an iOS project, which requires developers to have a Mac, Android projects can be developed on macOS, Windows, or Linux. You can download the Android Developer Tools bundle from the Android Developer website, which contains everything you need. Or, if you already have Eclipse installed, you can manually download Android SDK and install the Eclipse ADT plugin separately. The steps just discussed have also been covered in the PhoneGap platform guide page. After the Android SDK has been installed, we're going to add Android platform support to our Hello World project. In the project folder, run the Cordova platform add Android command. It could take a while to initialize your native Android application. Then run the Cordova prepare command to stage our web code to native mobile platforms. Just as for the iOS platform, PhoneGap commands allow you to build and deploy your Android app. We use the Eclipse ADT plugin instead for future plans. Open Eclipse with the ADT plugin and click on the File menu and then on Import. Insert the existing Android code into the workspace. Locate the Android folder under the Platforms folder in our Hello World project. Then after importing, if you see a red cross sign at your project icon, it means the project has not been assigned to the correct version of Android SDK. Generally, you need to fix it manually by performing the following steps. First, right-click on the project folder. In the Properties dialog box which is displayed, select Android from the navigation panel. For the project build target, select the highest Android API level that you have installed. Click OK, and then from the project menu bar, select Clean. This should fix the library issue in the project. Now we can build the project and deploy it to the emulator. Before running the Android project on the emulator, we first have to create one. Click on the Android Virtual Device Manager button to set up an emulator. Give it a name and choose a template device. The API level should match that of our project, which, in this case, is using Android 4.0. Keep the rest default. Let's start the emulator. Let's get our app running. Right-click on the project icon and run as an Android application, and choose the running simulator. It should behave the same way as we saw previously. In this video, we've learned how to code our application and how to deploy it on mobile platforms. You should be able to build and deploy your own iOS and Android app now. So far, we've introduced how to use the PhoneGap platform. In the next video onwards, we're going to go into the details of hybrid app development. In the next chapter, we will learn about the essential development tools. In the previous video, we developed our first Hello World application on different platforms. However, real applications are more complex than a Hello World application, therefore we need a set of development tools. In this section, we will introduce some useful development tools and install. You first need to choose a code editor to develop PhoneGap applications, for example TextMate, Sublime Text, WebStorm, Eclipse, and so on. It is better to choose an editor that can work seamlessly with HTML, CSS, and JavaScript, since most of our development will deal with these languages. You also need to choose a WebKit-based browser, since our application will be running inside of a WebKit web view. Besides, WebKit-based browsers normally provide an inspector, which we will use to debug our application locally. For debugging applications running in mobile devices remotely from our computer, we need Weinre. Finally, we need a source code version control tool, which will help us manage our source code so that we can revert errors, share our code, and so on. In this course, we are going to use Git, which is a very popular version control tool. You can choose any WebKit-based web browser, such as Safari or Chrome. We are going to use Chrome. Download Chrome from this URL and install it by following each step shown here. Weinre is a remote debugger for web pages based on Node.js. You can install and then run Weinre locally, or we could simply use a Weinre instance hosted by PhoneGap. Visit debug.phonegap.com and follow the steps there. Node.js needs to be installed if you want to run Weinre locally. We've installed Node.js previously. After Node.js has been installed, you can install Weinre through npm. Use -g to install it globally so that Weinre can be executed from the command line. After it has been installed, we can run it from the browser. Use the browser to open this address. Then you can follow the instructions displayed. We use Git as our version control tool. If you are using a Mac, it comes with your macOS build. Otherwise, you need to go to this URL and install Git. It has everything you need. In this section, we have primarily set up our development environment. In the next section, we will talk about how to debug code. In this section, we will dig into how to debug our app through WebKit Inspector. WebKit Inspector allows developers to view the live DOM hierarchy, edit CSS on pages, and add breakpoints in the JavaScript. To start a web inspector, we first need to open a WebKit-based browser. Here, we will open Google Chrome. Once done, you can go to Menu, Tools, Developer Tools to open the WebKit Inspector. The Elements panel provides the HTML hierarchy and live CSS related to each of those HTML elements. The Resources panel contains the hierarchy of all of the resources, like HTML, images, videos, scripts, local storage, and so on. The Network panel lists what web requests your apps have performed. The Sources panel, which is a script panel, is where we debug our JavaScript code. Timeline panel shows the details of what's happening by time when your app is running. The Profiles and Audit panels can be used to test the app's performance. And the Console panel allows you to run JavaScript on the fly. The Weinre user interface is similar to that of WebKit Inspector. Start up the Weinre server or use the PhoneGap Weinre host. Copy the script tag and embed it into index.html, which is the file we will debug into. Then load the page in the browser. The browser will connect to the Weinre server automatically when the page is loaded. We can now debug the web application using Weinre. The Weinre layout is similar to WebKit Inspector. We will talk about how to debug the app later. We use our Hello World application as an example. Open index.html using Google Chrome. For reasons of cross-domain access security, it is better to set up a web server to host those web files, and we will come to that soon. Another alternative is to use the Cordova serve command introduced before. Open the inspector. In WebKit Inspector, we can override a series of browser settings like user agent, DOM dimensions, and so on. We change the DOM dimensions here to make it more like a mobile device's screen dimensions. We will now go to the Elements panel, where we can view the live DOM hierarchy, edit HTML tags, and change the CSS properties. To edit the content of an element, simply double-click on the content and change the text to whatever you want. Double-click on the element's attribute to edit it. We add a style attribute to the element here. You can also edit an entire element's HTML code, add extra HTML code, or delete an entire element. Your changes will be reflected only in the browser. If you refresh the page, the changes will be gone. The CSS of the elements are listed in the panel to the right. You can easily find out from where these CSS properties are coming. Besides, the inspector also lists the result of the computed style, which is the actual current CSS value for an element. To add styles to an element, double-click on here and type in the CSS name and value. As another example, let's bring the Click Me button to the center of the page and round the corners. To debug the JavaScript code, open the source panel. You can find all the loaded JavaScript files here. Let's open the index.html file, where we have put our JavaScript code. The embedded JavaScript code is also debuggable. Click on the line number to add a breakpoint. Click on it again to remove the breakpoint. Breakpoints pause the JavaScript from running when it reaches that line. When it is paused, we can check out the value of the variables or run the JavaScript code in the console. There is a toolbar on the top right, with which we can control the debug process. This button can be used to toggle between whether the inspector automatically pauses JavaScript from running when an error occurs, or it does not. In this section, we talked about debugging PhoneGap applications. You should be able to debug your application with either a computer or a mobile device. In the next section, we will introduce how to use Git to manage our source code. In the previous section, we've introduced how to debug our applications. In this section, we will talk about Git, which plays a very important role in application development. Git is a distributed version control system. It manages the source code for our application. To start with Git, we will create a new folder which will act as our workspace. We use the git init command to initialize this folder as a Git repository. It will track changes in that folder after initialization. Before committing any code, don't forget to set up your name and email. This information will be used to track the author of each commit. For the first commit, we normally create a README file and add something to introduce the project. The git status command is always used to check if we have made any changes in the Git repository. We can see that the README file is untracked, and we need to add it to a track. Use the git add command to add all files in the current repo to the track. Now, running the git status command will show you some uncommitted changes in the repository. We need to use the git commit command to commit those changes. Using the git status command now should output that there is nothing to commit. The git branch command is used in multi-developer and parallel development. By default, Git will automatically create a master branch after the first commit. To create a new branch, use the git branch command with a new branch name. the new branch is created. The branch name with an asterisk in front is the current branch. To switch the current branch to our newly created branch, we need to use the git checkout command. Here we go. The current branch is named new branch. The new branch should contain the same content and commit history as the old one when it is created. The changes made in this branch will not affect the old branch. Now we commit some changes to the new branch and check out the old branch. As we can see, it's not affected at all. We can use the git checkout command with -b to create a new branch and check it out. Since it is created based on the master branch, it doesn't reflect the changes we have made in the new branch. We can use the git merge command to merge commits in the other branch into the current branch. Most of the time, the git merge command works fine. However, when two branches have changed the same file in the same line, the git merge command will raise a conflict error while merging. Let's have a look at an example. Say we are in another branch and change the file's name to new file in new branch. We add something at the first line. We then commit the change to the current branch. Check out the new branch. Edit the file. We put something different in this file. Commit the change in this branch. Now, if we merge another branch into the current branch, it will output an error saying there is a conflict. We need to solve the conflict manually by editing the conflicted files and then committing those changes. The git status command will help us find out which files are not merged. Now we commit the changes to solve the conflict. Reverting changes is one of the most powerful features of Git. Here are the most commonly used reverting commands. We will introduce them one by one. The git reset command allows you to reset a specific file to a history state, or set the current branch head to a history commit with or without replacing the current working tree. As an example, let's create a file and add some contents. Commit the change. The git log command lists the past commits. Use it to have a look at the commits. We make some more changes to that file and commit them. Then we want to reset the file to the old version, when we made the first change after creating the file. The commit should be named ch1 test file. Copy the commit hash. This will copy the content of test file from the ch1 test file commit to our index tree. It will not affect the current working tree. That is why we see an M flag in front of test file. You see, the content of the file in the current working tree has not changed. We can use the git checkout command to check out the content of that file from the index tree to the working tree. The file content has been changed. Now, running the git status command will say there are differences between the index tree and the head branch. Finally, we need to create a new commit for this change. The reverting has been completed. The git reset command can also set the current branch head to a past commit. The option hard will reset not only the head branch, but also the index and working tree. You need to be careful since any tracked changes after the reset past commit will be discarded. As an example, we reset to our first commit. You will note that all the changes are gone permanently. Through the git log command, any commits after the first commit are discarded. The git revert command reverts changes made in one commit and generates a new commit based on those changes. It requires your working tree to be clean. For example, we create a new file in the current branch and modify the file in several commits. Here we have them in the commit log. Now we want to revert the changes made in the last commit. Unlike the git reset command, which directly sets the current head branch to the last commit, the git revert command will reverse the changes of that commit and create a new commit for the changes. And don't forget your revert commit messages. If we use the git log command to check the commit history, we will see the commit it created. Let's check the content of the file. Note that the change made to this file in the last commit was reverted. The git revert command sometimes causes conflict if the reverse changes of some files in that commit conflict with the changes of the commits afterwards. Just as with the git merge command, we need to solve these conflicts manually. The last command we are going to introduce is git clean. It simply removes untracked files from the working tree. Be careful, those untracked files will be removed permanently. We create a new file for demonstration purposes. Use the git status command to show all untracked files. Now clean them. They are all gone. Git has many other useful commands, and we will cover them in upcoming videos. In this section, we simply introduced how to use Git to manage our source code. In this chapter, we have prepared tools we will need before development. In the next chapter, we will dive into cutting-edge web technology, HTML5 and CSS3, and also explore how to use the PhoneGap API. In the previous section, we have introduced some development toolsets and shown how to use them. In this section, we will focus mainly on the HTML5 and CSS3 web technologies. This video is going to talk about HTML with regard to two areas: Introduction to HTML5 and how to optimize DOM resources. Before we start, we need to discuss and solve a problem: screen size. Mobile devices always have different screen sizes, screen resolutions, and pixel densities. This means our web page may look different on different screens. For example, if we develop a web page for a 3.5-inch iPhone screen with a resolution of 320 by 480, the web page will be 1/4 of the size on a 3.5 iPhone with Retina screen. If we open the Hello World web page in a Retina device's browser, it will appear quite small. The same problem occurs on Android and tablets. To solve the issue, we need to add a viewport meta tag in the HTML page. Now it looks correct, and the user's scalability is disabled as well. To use HTML5 features, we need to enable HTML5. Add a doc type at the beginning of our HTML document, and this informs the browser that we are going to use HTML5 features. Canvas is one of the most powerful HTML5 features. It can be used to generate fast and dynamic graphics using JavaScript. Most mobile devices support it. For example, I will create a signature component using Canvas. First, add some basic HTML code and the meta tag that was introduced before. Then we create a canvas element with a specific ID, width, and height. We also add a border to make it more prominent. After that, we create a JavaScript file and write the signature component there. Create a signature module so that all the JavaScript code is running inside the closure. Think about the signature process first. When the user touches the canvas, the signature starts, and the canvas draws lines when the user moves his or her fingers on the screen. The signature process ends when the user's finger leaves the canvas. Therefore, we need a variable to flag whether signatures have started or not, two variables to keep the coordinates of the last position of the user's finger, and a canvas element and the context inside it. Now we need to get the canvas and the context object when the document is loaded. We can use jQuery's document ready command if we're using jQuery. Use the document's getElementById method to get the canvas elements. Then get the 2D context object from Canvas. After that, we need to write some functions to handle the signature process. We first write a start signature function. This function mainly changes the isBegin variable and gets the initial coordinates. We need to get the coordinates from the event object, and we write a helper function to do so. Since there is no offset x or offset y in touch events, we need to calculate them ourselves. Use the event's client position, which is the relative position to its target's container, minus the canvas's offset position, which is the relative position of the canvas to its container. Now we write the start signature function. The end signature function acts in the opposite manner. It sets the isBegin variable to false and cleans the last coordinates. Then we write the draw signature function. It first checks whether the signature has started, and then draws a line between the last coordinates and the current coordinates. The begin path method starts a path that will be used to draw the line. The moveTo function moves the cursor to the mentioned coordinates. Then the line2 function adds a line to the path. Finally, the stoke function draws the path. We then use the current coordinates as the last coordinates. Now we need to attach those functions to Canvas elements. Then we link the JavaScript file to index.html and try it in Google Chrome. It seems to be working well. Let's try it on a mobile browser. In most situations, mobile browsers perform in a similar manner to what we see in the app. Here we have an issue. The window moves up and down. We can solve that by preventing browser default actions. Try it again. It works! Video and audio tags in HTML5 are used to create video and audio streaming. It's very simple to use. You can either use JavaScript to control it, or use the built-in control panel. For example, I've created a video tag streaming an MP4 video using the built-in control panel. Let's see how it works in Google Chrome. Different mobile devices will handle it differently. For example, iPhone devices will use the built-in QuickTime player to open the video in full screen mode. While on iPads, it will play as an embedded video, and the user can manually open it in full screen. Geolocation allows the user to share their geographical position. It is widely supported by almost all mobile browsers. It is as simple to use as coding a one-liner JavaScript code. Using geolocation with Google Maps can tell the users where they are on the map. We can find the latitude and longitude of our position too. It is the same on mobile devices. The local storage allows the app to store lightweight data for offline use. The size of the data is usually less than 3 megabytes. Here we write a simple example to save and load data. The example will load and display the stored name and allow the user to set a new name and store it. The getItem method will get the value of the key. Null will be returned if the key does not exist. The setItem method takes two parameters, that is, the key and the value of the key. We reload the page after it is set. OK, let's see how it works on the browser. It should behave in the same manner on mobile browsers. HTML5 supports advanced forms. This feature is more prominent on mobile devices. Mobile devices render the input in a native manner. However, it's not fully supported and will fall back to using the original text input if the device does not support it. Since the PhoneGap mobile application is working on a single page, it's very important to arrange your page elements in an efficient manner. Although the DOM can handle infinite elements, devices have limited computing resources. We need to remove unused elements from the DOM and add them back dynamically. We can also easily load images in an image list and display images that can only be seen by the user. In this video, we have introduced how to use HTML5 in a mobile application. In the next video, we'll talk about CSS. In the previous video, we talked about HTML and HTML5. In this video, we will talk about CSS and CSS3. The CSS introduced in the first half of this section has been proven to work on most devices. However, we need to be careful when using the CSS discussed in the second half of this section. For most CSS3, we can use a neat tool called CSS3 Generator, which can be downloaded from this URL. Here, I have mainly demonstrated how it looks and what we need to take care of before using it. The border radius property sets the radius of the four corners of a DOM element. It uses few resources. The box shadow property adds a shadow under a DOM element. It uses few to medium resources, depending on the size of the shadow and the blur radius. Text shadow property is similar, but adds a shadow under the text. It likewise uses few resources. We can create an iOS-like embedded text effect easily with this. The RGBA allows an extra alpha channel to set the opacity of the color. It uses few resources. The gradient function creates a gradient of color. It actually creates an image. It uses a lot of resources. Avoid using it with a long list. The transformation applies a transformation to an element. It uses medium to high resources depending on the complexity of the transformation. Here is a list of CSS that we should use carefully. The fixed position property fixes an element at a certain position on the screen. However, it doesn't behave as we expect it to on most devices. Avoid using it as much as you can. The overflow scrolling property is widely required in mobile applications. However, it does not work as expected on some devices. Even on iOS 5 and 6, which provides scrolling that has a native feel, it doesn't render the scrolled elements properly. We can use an alternative solution, such as iScroll. The transition property adds animation to DOM elements when CSS changes. It performs well in most situations. However, it is slow even on the latest iPad when the number of elements in the animation is large. In this video, we've introduced some HTML5 and CSS3 features. In the next video, we will talk about JavaScript and some libraries. In the previous section, we've introduced some HTML5 and CSS3 features, which are mainly used for UI construction. In this section, we'll gradually go through how to build an app with the help of frameworks, how to optimize JavaScript code, and how to increase the quality of JavaScript code using unit tests. In this video, we will mainly focus on a framework called Sencha Touch and demonstrate how fast an app can be built with Sencha Touch and deployed to mobile devices with PhoneGap. JavaScript has a very long history. We use the JavaScript 1.5 standard for the whole course, which is currently the most popular and widely supported version. There are major differences between PhoneGap mobile application development and web page development. All those differences indicate that PhoneGap mobile applications are more like a rich internet application with the accessibility of device functionality. The client of the PhoneGap app is relatively more complex. We need to be more careful when designing the JavaScript code structure. To simplify mobile app development, we usually use a framework. Frameworks help a lot with regard to cross-platform functionality, code quality, and development cost. We can use frameworks to develop feature-rich and high-quality apps with little effort. We will introduce two frameworks in this course, Sencha Touch and jQuery Mobile, both of which have very good features. Sencha Touch is a high-performance HTML5 mobile application framework. You can use Sencha Touch to produce a native app-like experience inside a browser or in a hybrid shell. Sencha Touch supports Android, iOS, Windows Phone, Microsoft Surface Pro and RT, and BlackBerry devices. Sencha Touch allows developers to build UIs quickly without worrying about the difference between mobile browsers. The detailed Sencha Touch documentation helps a lot if you want more details, and it's not difficult to master. It contains development tools that help manage Sencha app development. Besides, Sencha Touch is based on the model view controller pattern, which is also applied to Sencha Touch apps. It dramatically increases the readability of applications. Sencha Touch is now at version 2x. Before using it, we need to check if our system meets the basic requirements. First, download the Sencha Touch SDK from the Sencha website. Keep in mind that the versions will differ according to whether your project is commercial or open source. You can skip this step if you've downloaded the SDK before. Then, check if your Java and Ruby versions meet the requirements. Open a terminal, type in java-version and ruby-v to see if the version meets the basic requirements. Once Java and Ruby are in place, we need to install the Sencha command line tool, which manages the Sencha Touch project lifecycle. Download the Sencha CMD package from the Sencha website. Run it and follow the steps to set up the Sencha CMD tool. After installation, run Sencha in the terminal and you should see some output. If you got any errors, check the requirements and reinstall. In this video, we simply introduced some reasons why we should use a framework for app development and how to install the Sencha Touch framework. You should be able to install the Sencha Touch framework, which will be used in the next video. In the next video, we will demonstrate how to initialize, develop, and deploy a Sencha Touch-based mobile application. In the previous video, we learned some of the basic concepts of app frameworks and installed the Sencha Touch framework. In this video, we will demonstrate how to develop a mobile application using Sencha Touch and deploy it to mobile devices using PhoneGap. In this video, we will also introduce a model view controller pattern, which is the recommended structure of a Sencha Touch app. Meanwhile, we will also learn how a Sencha Touch app can be organized. We installed Sencha Touch in our last video. Here, we will create a Sencha Touch app and deploy it to a mobile device within minutes. You will also find how powerful and convenient it is to write a mobile app with the Sencha Touch framework. First, open a terminal, create a folder for your project, and change directory into that folder. Then, extract the Sencha Touch SDK zip file downloaded in the last video and copy the contents to the project folder. You should see the content in your project folder as shown. Run the command sencha generate app sencha demo in our project folder. This will generate the basic structure for the Sencha Touch app. If you fail here, you need to take a look at the requirements again. Once the generation is complete, we will have created our Sencha mobile application. We can now view it in the browser. In the project folder, run the command sencha fs web start. Sencha will create a simple web server. Open the web server URL in the browser, and you'll see how your application currently looks. Now we will make some changes to the app. The Sencha Touch projects follow the model view controller pattern, which is being used in all of your PhoneGap mobile applications. Basically, the controller controls the view and model to perform methods based on user action. The controller subscribes the user action events from the view. The view subscribes data changing events from models and renders the UI based on data returned from the models. Models define business logic, which contain data processing and data exchange. Now, in our project, open the app.js file. The Sencha command line tool generates the code here automatically, and we generally don't need to change it. We will introduce our application and Sencha Touch from here. Sencha Touch has very detailed documentation. Open a browser, go to docs.sencha.com/touch. The first line of the code is ext.loader.setPath. In the documentation, we find that this line sets the source path for the ext namespace. We can ignore it for now as it has little value. The next statement is ext.application with a JSON object as the parameter. In the documentation, we find the explanation of these parameters. The most important one is the defined launch function, which will be called to render the initial UI when the app is ready. We can find that the generated code added the main view to the viewport. To change the application, we need to change the main view. If you want to change some other functions, such as a user event handler or data processing, you will need to change the controllers or models. We can see a view folder which contains all views, in which there is a main.js file which has our code for the main view. It's possible to find the explanation for the parameters in the Sencha Touch documentation. I will simply introduce them to you here. ext.define on the first line will define a namespace for a Sencha view object. It extends from the ext.tab.panel, which means that the view has all features of a tab panel. Then it gives its unique X type and declares that the view requires a Sencha Touch title bar and video components. After that, its config defines the position of the tab bar. The items parameter declares the children items inside the components. Now, the component has two items. Each item is a standalone Sencha view object. The first item is the welcome page with a title bar docked on the top. The second item is the Get Started page with a video content inside. This is how a nested Sencha Touch view works. You can either define a view in a single file and refer to it in another view, or embed the view definition in the view directly. As we understand the view structure, we will also go about changing the items in the main view. We first remove all the existing items and add one item with the title About, which will be displayed in the tab bar and a star class as the tab title icon. In the HTML code, we simply say Hello World. After refreshing the browser, we can see that the change is applied immediately. Now we can add the title bar, which is regarded as an embedded item in the About page. Let's dock the title bar on the top with the title Sencha and PhoneGap and refresh the browser. We will see that the title bar has now been generated. Now we have a basic mobile app with both the tab bar and the title bar structured in minutes with no more than 20 lines of code. Once the Sencha Touch app is developed, we will be able to use the PhoneGap commands introduced to deploy an app to mobile devices. The steps are as follows. First, we need to add the Cordova script file to index.html. This will enable our Sencha Touch app using PhoneGap APIs. Then run the Sencha app build command, which builds a production version of your Sencha Touch app. Remember the location as we'll be using it later. Use the Cordova create command to create a new PhoneGap app. Copy and paste the production files from the earlier location to the Cordova project's www folder. Remove the Hello World project first. Finally, use the Cordova command line tool, add supporting platforms, and run the Cordova prepare commands. This is how we deploy it to an iOS emulator. Now run the application directly without any changes. In this video, we used the Sencha Touch framework to build an app and deploy it to a mobile platform using PhoneGap. Sencha Touch is a comprehensive mobile application framework. For more information, please check out the Sencha Touch documentation. In the next video, we will introduce another app framework, jQuery Mobile. In the previous video, we introduced the framework and discussed how to use Sencha Touch to develop a PhoneGap mobile application. In this video, we will introduce another framework called jQuery Mobile and discuss how to deploy jQuery mobile applications to mobile devices using PhoneGap. jQuery Mobile is based on the jQuery framework, which is a cross-browser JavaScript library designed to simplify the client-side scripting of HTML. jQuery contains a series of features like DOM and CSS manipulation, HTML event methods, AJAX, animations, and utilities. The jQuery mobile application is HTML5 based. jQuery Mobile supports more mobile device platforms compared to the Sencha Touch framework. I will demonstrate how to write a jQuery mobile application with a simple page and business logic. First, download the latest version of jQuery and jQuery Mobile. Here, we need to download jQuery 1x rather than jQuery 2. Create a folder for our project. Inside it, create the CSS and JavaScript files. Then, copy the jQuery Mobile CSS file and images folder to the project CSS folder. Also, copy the jQuery Mobile JavaScript file to the project's JS file. Finally, copy the downloaded jQuery JavaScript file to the JS folder. Now we have imported the jQuery Mobile libraries into our project. The next step is to create an index.html file to link those libraries. Now we add our first jQuery Mobile page. jQuery Mobile uses HTML5 data attributes to identify the functionality of a HTML element. For example, a div with data role as page is defined as a full-screen page in jQuery Mobile, and a div with data role header, in the example, will be rendered as a fixed page header at the top. Let's take a look at the browser. Unlike Sencha Touch, which creates a web server for the preview, you can either open the file directly in the browser or create your own web server for the project. To complete the page, we add a content div. In the content, we allow the user to choose the note type. The code is just pure HTML. We add two notes, meal and shopping. Then we insert an input box for the note text and an inline button that adds the notes to the list. Finally, we insert an empty list that will render the note data. Let's see how it looks in a browser. The page looks good, but interaction is not supported on it. We create an app.js file in the JS folder and link it to index.html. We know when the user clicks on the add button, it needs to add a note. We create an add note function to do so. We use the HTML5 local storage API to persist the data. When a note is added, we need to read the existing data from local storage and append the note to the existing data and save it back. Once we have something in local storage, we need to render it to the list item. In the render list function, we load notes from local storage first, and then loop through each item and append the item to the list element. Then we need to call the jQuery Mobile method to refresh the list view and effect the changes. Then we add a clear list function to clear the list on the DOM. Next, we need to render the list and bind events to the add button once the document has been fully loaded. Once the add button is clicked, we grab the current note type and note text from the DOM elements and generate a note, Then we store the note using the add note function. After that, we clear the DOM list and re-render it. Let's see how it works on a browser. So far, we have successfully created a jQuery mobile application. Now we wrap it with PhoneGap so that it can be deployed to mobile devices. Create a PhoneGap project. Remove the demo app. Copy all assets from the project folder to the PhoneGap www folder. Then add iOS platform support and run the Cordova prepare command to stage the source code. Then add iOS platform support and run the Cordova prepare command to stage the source code. Open the generated Xcode project in Xcode. Here's what it looks like on an iPhone emulator. In this video, we have demonstrated how to develop jQuery mobile applications and deploy them to mobile devices. There are many good web application frameworks out there, like Backbone.js, Require.js, and Angular.js. The point of this video, however, is not to introduce all those frameworks in detail, rather how to wrap those web applications with PhoneGap so that you can deploy them to mobile devices. In the next video, we will talk about JavaScript object-oriented programming, modular, and testing. In the previous video, we developed a mini notebook, which is a jQuery mobile application. In this video, we will mainly focus on how to increase the quality of our project and demonstrate this with the mini notebook app. JavaScript is not like most object-oriented languages, which have explicit class definitions. In JavaScript, a class is defined as a function, and its prototype is used for inheritance. Now we will refactor the mini notebook app to use OOP. The mini notebook can store the user's note text and render all the notes to a list. We have the class diagram, in which the persist class will persist and read the note text. The note class has two child classes which are responsible for the meal and shopping notes. Also, the DOM list class will render the DOM list with data from the persist class. Let's see the code. For the sake of convenience, we create a persist.js file for our persist class. We first create a persist function that will be used as a class. Then we define methods on its prototype. The first is the storeNote methods. We copy and paste the existing code from app.js. The second method is getNotes, which will return the note array. Again, we reuse the existing code. Now, when the script is loaded, we would like to initialize a persistence instance. Use the new keyword followed by our persist function. The persist object now has the storeNote and getNotes methods. In the same way, we create the DOM list class. It needs a parameter in its constructor. We add the clearList and renderList methods. Finally, we create a note.js file. Create the note class and its addNote method, which simply passes the note text to the persist object. Then, the mealNote class inherits from the note class by initializing the note class and passing the instance to the mealNote class's prototype. This is how prototype inheritance works in JavaScript. Now, we end the class by overriding the methods. Do the same thing with the shopping note class. Go back to app.js. We still need some code here to use our classes. When the document is fully loaded, we initialize a new DOM list instance and render it. Then, according to the input type that the user chooses, we initialize different note classes. Pass the user input to the note class and refresh the DOM list. Then add a reference of the JavaScript files to index.html. The app should now work the same as before. Modularizing is another way to organize your JavaScript code and increase your project quality. In JavaScript, we use closure to define a module. Here is an example. Assume we want to develop a map module for our app. It has two interfaces. One displays the user's current location on the map, while the other simply returns the reference of the map object that's encapsulated in the module. It requires an interface from another module to dispatch events. Since JavaScript is an event-driven language, we can provide an event interface, which is triggered when the user's location changes. Also, it requires an app-ready event. This will trigger the module initialization process when the app is ready. Let's see how it looks in JavaScript code. First, it uses a closure function to create the map module in our app. The map module could already exist, and it will extend and override the interfaces. The first two lines define the exported interfaces. To make the interfaces of the module prominent to other developers, we put them at the beginning of a module. The getMapObject function returns the reference of the private map object, which is not globally accessible. Events interfaces are defined next. Since there's no actual function to describe an event interface, we put some comments in to say that this module provides a location change event. Event subscribing is quite common. We have used it in the Hello World application tutorial to handle the device ready event. Finally, it depends on an interface called dispatchEvent, which is provided by the events module. With PhoneGap mobile applications, we can use some testing frameworks like Mocha. For browser testing, Mocha provides a template that can be found on their website. Let's see how to add tests to our mini notebook application with the help of frameworks and templates. Once we have the template ready, we create a test cases folder. We write a test for the persist class for this demo. The test case uses BDD syntax. It first generates a note text and stores it to persist. Then it loads back from persist and asserts if it contains the generated note. Once the test case is created, we need to add both the source module and the test case to our test.html file. Open the test.html file in a browser. Check if the test passes. In this video, we primarily introduced how to use PhoneGap along with some popular app frameworks and how to improve the quality of PhoneGap project. In the next video, we will learn how to use PhoneGap APIs. In the previous section, we talked about how we can write a high-quality project with the help of some tools. In this section, we will learn how to use PhoneGap APIs and the external PhoneGap plugins. I will take you through some of the APIs in this video. PhoneGap hooks native functionalities to our APIs so that we can call them using JavaScript. PhoneGap APIs provide interfaces to our applications to invoke native functionalities such as camera, geolocation, and accelerometer. Currently, the PhoneGap built-in APIs are imported to the application as plugins. We can use external plugins or develop new plugins to extend the PhoneGap API. To use the PhoneGap API in PhoneGap 3, which is the current version, we need to use the Cordova plugin command to add the plugin to our project. For example, if we want to use the native camera, we need to run the Cordova plugin and add the package name of the camera. Once it's added to the project, we can then use the JavaScript API to use the camera to take pictures. The Cordova prepare command will automatically stage added plugins to all target platforms. We download jQuery Mobile and create a basic project structure. Create an index.html file and input some basic jQuery Mobile HTML elements. Create a PhoneGap project using the Cordova command line tool. Here is a demo app introducing how to use the PhoneGap API. The app is jQuery Mobile based and will demonstrate some PhoneGap APIs. The camera API is used to take a picture and the package name is org.apache.cordova.camera. Use Cordova Serve to preview it in the web browser. We need to add it to our project through the Cordova command line tool. The demo will take a picture and display the photo on the screen. First, we create an app folder. Inside this, we create a camera.js, which will include the JavaScript code for the camera. We then create app.module. the module will export a start camera function which will call the PhoneGap API navigator.camera.getPicture. This function takes two parameters, a successful callback function and a fail callback function. The successful callback function will be called if the photo is taken successfully and the URL of the photo is returned, while the fail callback function will be called with any failure messages. You will need to link the script file and add essential click events. Let's see how it works. The geolocation API returns the current device location. The package name is org.apache.cordova.geolocation. Now let's add it to our project. Similar to the camera function, we create a geolocation JavaScript file and an app.geo module. The module exports the showLocation function which calls the PhoneGap API navigator.geolocation.getCurrentPosition. The callback function will contain a position parameter which includes the current latitude and longitude values. We can pop these values to the screen. Let's now take a look at the demo. The accelerometer API returns the device motion. The package name is org.apache.cordova.device-motion. Add the plugin to our project with the Cordova command line tool. The usage of the accelerometer is similar to that of geolocation. We create the module and call the PhoneGap API navigator.accelerometer.watchAcceleration. The function will constantly call the success callback along with the current device motion. The frequency parameter tells how often to return the result in milliseconds. That is, we pop the values of the X, Y, and Z axes onto the screen. This is how it looks on the device. The direction values change while I move the device randomly. In the code, we can see the acceleration change at line 7 and pop the result to spans. Here is how it works. The number changes when I shake the device. The package name is org.apache.cordova.device-orientation. Let's add it to our project. Add a compass.js file and a compass module. We export the startWatch function which will start to watch the change of current device direction. This function will register a watcher which is returned from the PhoneGap API navigator.compass.watch heading. Similar to the accelerometer API, it needs to decide the frequency of returning the device direction result. We then implement the handlers to populate the result or display an error message if the operation has failed. We can also stop the watcher by using the PhoneGap API. Aside from the JavaScript methods, PhoneGap defined a series of events which hook to the native events such as device ready, app pause, app resumed, offline, and online. It's important to use these events for app lifecycle management. The device ready event is fired when the device is ready to use the PhoneGap API. All the PhoneGap API calls should be called after the device is ready. The pause event is fired when the app is put in the background, while the resume event is fired when the app is retrieved from the background. As seen in the code snippets, PhoneGap events are fired on the document and the callback function will be called when the events are fired. Here are some more events. Each of them is very useful. Check the PhoneGap documentation online for more information about these events. In this video, I introduced how to use the PhoneGap APIs through a demo app. In the current version of PhoneGap, the PhoneGap APIs are also PhoneGap plugins. You should now be able to use any of the plugins from the PhoneGap plugin repository. Since Cordova 3 completely changed the way its plugins are built, most of the existing powerful plugins working in Cordova 2 do not work with Cordova 3. In the next video, we will learn how to use the legacy PhoneGap plugins in Cordova 2. In the previous video, I introduced how you can use built-in PhoneGap APIs. However, when you require functions in addition to the built-in ones, you'll need to use the PhoneGap plugins. In this video, we will demonstrate how we can use PhoneGap plugins. The demo in this video is based on PhoneGap 2 rather than the latest PhoneGap 3 version, as PhoneGap 3 has made some changes to formalize the plugin usage. However, PhoneGap 3 based apps can also use this video as a guideline to import the external PhoneGap plugins. PhoneGap plugins encapsulate complete and standalone functions such as barcode scanner, Game Center integration, and PayPal integration to extend the PhoneGap app's native functionality. The built-in PhoneGap APIs are actually plugins as well. Plugins can be found all over the internet. Most of the good plugins are assembled in the PhoneGap plugin repository on GitHub. We can clone the Git repository and keep everything up to date. Now, how to use an existing PhoneGap plugin. PhoneGap plugins always have a very detailed documentation to help the developers to install and use the plugin. It's good for us to understand the structure of a PhoneGap plugin. In general, a PhoneGap plugin contains a web part and a native part. The web part includes our application logic, which calls the JavaScript hooks. The JavaScript hooks then call the corresponding PhoneGap plugin interface. It's a part of the PhoneGap plugin source files. The native source files may depend on other native packages, and both the plugin source file and dependencies may require app configurations such as app permissions. Therefore, we need the following steps to import a PhoneGap plugin. Include the native source file to the compile path, include the JS file to the www folder, include the plugin to the PhoneGap configuration file, include the dependencies to the project, then change the app configuration by adding or removing permissions. After following these steps, we can use the plugin in our app and build the project. Here, I give you a demo on how to use the barcode scanner plugin. Check out the PhoneGap plugin Git repository before the demo. First, initialize a PhoneGap Android application and import the project to Eclipse. Now, we follow the steps that we introduced earlier. The first step is to include the source files. This requires a new package. Then, we copy the Java source file from the plugin folder to our project. The second step is to include the JavaScript file. Create an index HTML file, copy the barcode scanner JavaScript file from the PhoneGap plugin folder to the project, and link it to the index.html file. After this, we need to add the barcode plugin to the PhoneGap configuration of our app. Open the res/xml/config XML file and add a plugin element. The value should be the same as the path of the barcode scanner class. The next step is to add dependencies. The barcode scanner class needs a capture activity to capture the photo stream. This dependency is also packaged with the barcode scanner plugin. We import it as a library and add it to our current project. The last step is to change the project configurations. For the barcode scanner, we need to add 3 activities. You can find them in its README file and simply copy and paste them from there. After these activities are created, we need to set up the app permissions. The barcode scanner needs to use a camera and a flashlight. Now, let's finish our application code so that it will invoke the barcode scanner. Okay, now let's deploy the app to a real device to see how it works. In this video, I have introduced how to use a PhoneGap plugin. With the help of this video, you should be able to use hundreds of plugins. In the next section, I will simply introduce you to some server-side technology and how a PhoneGap app talks to a web server. In the previous section, we used PhoneGap plugins in Cordova 3 and legacy PhoneGap plugins in Cordova 2 projects. PhoneGap-based mobile apps are a combination of web apps and their proper usage of PhoneGap plugins. In most of the projects, a PhoneGap app is not enough to solve all of the problems due to the limitation of web technology and PhoneGap itself. In this section, we will talk about server-side technologies, which make your app more powerful. The first question is, why do we need a server, or how can a server-side technology help us with our projects? Obviously, with a server, it's possible to process and store data produced on our client. For example, a social app will need to store its user profiles. Secondly, a server could help with integration with external services. It's especially useful when external services are not web technology based. Furthermore, if you are an enterprise player, a server is necessary to isolate your servers from public access. It's recommended to write your server-side project with Node.js. We have used Node.js in the previous sections, like the Cordova command line tool is Node.js based. It is fast and reliable, and there are loads of libraries in the npm repository. The most important thing is that we just need to know JavaScript. No other languages are needed. If you prefer to use other technologies like Apache and PHP or IIS, there is no problem with this. We will use MongoDB as our database, since it's easily integrated with Node.js and it uses JSON as its data structure, which JavaScript developers are familiar with. Also, if you prefer using any other database, this isn't a problem at all. If you choose Node.js and MongoDB, the Feed Henry platform may be a good choice for you. It delivers end-to-end mobile cloud solutions. It brings in extra security and reliability to your project, and you could scale your box according to your requirements. The Feed Henry platform is fully compatible with any of the PhoneGap apps or native apps. It's powerful and easy to use. Since our PhoneGap app is web-based by default, we could connect to the server using a web request or a WebSocket. With the help of PhoneGap plugins, we will be able to connect to our server through other TCP or UDP-based protocols. Due to the limitation of web technology and PhoneGap, a server-side technology is needed in most situations. Here I have quickly introduced some of these technologies, and in the next video I will start with a demo project. In the previous video, we saw why we need a server-side technology for our PhoneGap apps, and what technologies are recommended. In this video, I will give you a demo of how to write a mobile app with the server-side technology. Before the demo, you will need to have installed Node.js and MongoDB correctly. The app will simply allow the users to register, log in, and view a list of registered users. Let's initialize our project. First, we create a client folder and a cloud folder in our workspace. We create a Cordova project in the client folder using the Cordova command line tool. Remove the generated content in the www folder. The client is as simple as 3 pages, and we will use jQuery Mobile as the framework. First, we create an index HTML file and essential HTML structures, and import the jQuery Mobile libraries. We add a page container for all the jQuery Mobile pages. Then we create an app folder in which we store our application. Create the app.js file and root.js file in the app folder. Open the app.js file. We will first initialize all modules. When the document is ready, we initialize the page container and load the first page from the router. The router has not yet been implemented, so we leave a to-do here. We open root.js and add some code. The code will mainly be using the jQuery Mobile API to navigate through pages. Open app.js. Now we can call root.firstPage when the document is ready. The first page is the login page. The jQuery mobile will try to load the login.html file into our page container. We add some HTML code in the login.html file with 2 input boxes and 2 buttons. Add the JavaScript files so far to the index.html file using the script tags. Let's see how it looks in the browser. Now we add the second page file, register.html. The register page allows the user to register their account or go back to the previous page. The HTML code is straightforward. So far, we have 2 pages, but we don't have any business logic to connect them. We will implement some controllers. Create a controllers folder under the app folder with a login.js file in it. The login.js file will include all the business logic on the login page. Currently, it contains only the register function, which will be called when the user clicks on the register button on the login page. It will bring the user to the register page. In login.html, we add an on-click listener to the register button. The listener will call the login controller's register function. Link the scripts to index.html. Now, if we click on the register button, the app will be navigated to the register page. Similar to the login page controller, we can add the register controller for the register page. Similar to the login page controller, we can add a register controller for the register page. The controller will mainly register a new user account on the server. We leave the register implementation empty for now and just finish the on-click listener on the register button. Let's go back to our empty register implementation. It will first retrieve the username and password from the input boxes and then check if they're empty. Since it needs to call the server side, we display a loading icon. Next, it needs to call a model to register a user and render the response to the UI. Create a models folder under the app folder. Add a user.js file into the models folder. The user model will be responsible for user-related web requests, such as register, login, and retrieving the user lists. We could create a reusable web model to handle all of the web requests. The web model makes use of the jQuery post method to send a request to a URL along with its parameters. It will call back the data or error if the request fails. The base URL is the URL to the server. It can be changed to a real server URL. Go back to the user model. Remove the to-do and use web model to call the register method with the parameters to the server. Open the register page controller and call the user model's register method. The parameter here is the username and password from the input boxes. When the web request finishes, it will first hide the loading icon. Then it will check if there's any request errors or if there's any errors popped from the server side. If there is an error, it means that the registration failed and the user needs to read the error message and try again. Otherwise, the app will navigate the user to the login page. So far, we have developed a part of our client with model, view, and controllers. Now, the client needs a server to register the users. Create package.json in the cloud folder. It will contain the meta info such as the name, version, and dependencies of our server. Go to the command line and change the directory to our cloud folder. We need to run npm install to install the dependencies. Once the dependencies are installed, create an application.js file. We use express.js as a web framework. We add a post request handler for user registration. The handler will receive parameters passed from the client which posts to the URL. Similar to the client, we will use a user model to process the data. Create a libs folder. Since the user model will need to access the database, we create the DB model first, which will be responsible for the database access. The DB model creates a MongoDB client and connects to MongoDB with a connection string. Once the DB connection is initialized, the DB model will keep the connection for further usage. Now we create the user.js file. It will require db.js that we just created. Now create a register function. It will first get the DB client and request for a collection called user. With the collection object, it will insert the parameter passed directly to it. Go back to application.js. We can call user.register to register a user. The callback will check if any errors happen while registration is in progress. If there is no error, it will simply return OK as true. Now the client should be able to register a new account into MongoDB. Due to time constraints, we will skip the demo of the development of other functionalities which are very similar. You could check out related code. Let's take a look at the finished app. In this video, I simply demonstrated an app with both client and cloud technology and how they communicate with each other. The demo app will be used in the next video, where we will add more functionality such as camera usage. In the next video, I will introduce the Feed-Henry platform where you can deploy your server application. If you have other choices for your server app hosting, you can skip to next video. In the previous video, we developed a PhoneGap app with basic server-side functionality. We then created a platform to deploy to our server side. In this video, we will simply go through how to use the Feed-Henry platform to host our app. First, we need to create the Feed-Henry project. After logging in to Feed-Henry, navigate to Projects, New Project, then Bare Project. Our project name is My Demo App. The project will now be created. Then we need to integrate our server side to the Feed-Henry platform. We add a cloud app to the project. Navigate to Import Existing App, Cloud App, My Demo App, Cloud, and import from a bare repo. Click on Start from Scratch. It will show some help text to create a Git repo and push to the Feed-Henry Cloud App code repository. We follow the instruction to import our Cloud App to the Feed-Henry project. We add a git ignore file to exclude the node modules folder, which is not needed. Now, the code is in the Feed-Henry platform, but is not running. We need to make 3 changes in the code for it to run. First, we need to add some Feed-Henry dependencies and add several lines of code into the application.js file. Second, our app should listen on the port which is allocated by the platform. Third, the app should use the database connection string provided by the platform. Once the code has been pushed to the cloud, we can run and deploy the app. Click on the Deploy tab on the left column and click on the Deploy Cloud App button. Once the deployment is complete, the app should be running. Now we need to change our client so that it points to the new server. For this, copy the current host URL on the details page. In the web model, replace the base URL with our cloud host URL. Let's now run the app in the simulator. It works as expected. In this video, I deployed the server app to the Feed-Henry platform. There are lots of features in the Feed-Henry platform, such as zero-code app generating, building mobile app binary, and statistics. You can find more information on these features at feedhenry.com. In the next video, we will complete the demo app with more functionality using the PhoneGap APIs. In the previous section, we created a demo app which connects the PhoneGap app with the server side. We will extend this demo to a mobile chatting application. We will make use of the knowledge we gained in the previous videos, such as the Cordova command line tool, HTML5, JavaScript libraries, and server-side technology. In this video, we will go through the demo. Since the app is based on the demo app in Section 7, you need to watch Section 7 first. The project develops a mini instant messaging app, which sends text or image messages between two registered users. Here is the client architecture, which is a typical layered structure implementing the MVC pattern. We have implemented most of the components in the last section, and we will do the rest in this video. This is the structure of the server side. Due to time constraints, the session manager just uses memory to keep a map between the user and its connection session. Here are the core functionalities for this video. Some of you may have noticed that the app uses WebSocket for real-time communication. We use Socket.io in the application. With the power of this WebSocket-based message exchange engine, we could send images from PhoneGap Camera API or HTML5 canvas to our server. Socket.io is a Node.js component, which wraps an implementation of WebSocket. The component is fully compatible with the majority of mobile devices, so it is safe to use in our app. HTML5 WebSocket is a protocol that allows full duplex communication between a web browser and server-side on a single TCP connection. Unlike web requests, which are single-way, WebSocket allows the server to push messages directly to the client. To install Socket.io, just use npm install in your server folder. Here is the usage of Socket.io. On the server side, we find that it attaches to an HTTP server object. Whilst the client side is initiating the connection, the server will receive a socket object representing the connection session. Then, both the client and server side could use that socket to emit or receive messages. To add Socket.io into our app, we need to make some changes. First, in the cloud, as we are using Express.js, we need to get the HTTP server from the Express.js app. Then, attach Socket.io to the HTTP server. Finally, we need to use the HTTP server to listen to our port instead of the Express app. On the client side, in the index.html file, we need to add a script tag for Socket.io. We create a model for Socket.io. The model will first connect to our server and then subscribe to the data event, which will be triggered if the server sends any data. Then, the app needs to initialize a session once the user has logged in with user identifier by emitting a register event along with the user ID. The init function should be called once the user has successfully logged into the app. For this, we add a line of code to our login controller. On the server side, the Socket.io object subscribes to the connection event, which will be triggered when any connection is made from the client. Then, the socket subscribes to the register event to receive the register event from the client. We also subscribe to the disconnect event, which will be triggered if the connection is lost. Finally, we use a variable to keep the map between user ID and their socket connection. Although the client side could use Socket.io to send data, we use a normal web request to demonstrate how to use two communication methods. When a client posts to send an endpoint, it will post its recipient ID so that we could find the related socket object from the map. The socket will emit a data event to target the client along with the data received. On client, the chat controller will manipulate the chat view so that we could render text or image on the chat page. We skip the video as it is only DOM-related code. Then, we develop the content model, which sends text or image to the recipient. It exports a sendText function and sendImage function. Both of them use the send method, which is based on the web model. It will post the data type, data, and recipient ID into the server's send endpoints that we have defined earlier. The send message will return a response depending on whether the message was sent successfully or not. We change our UI according to the response. When data is received in the socket model, we forward it to the chat controller to display it. Once we have our message exchanging engine based on socket.io, we can send image or text messages. To send a photo from the gallery or camera, we need to use the PhoneGap API, which retrieves the base64 encoded image. Once the image data is retrieved, we call the chat component to draw the picture and content model to send the image to the server. We use navigator.camera.getPicture to retrieve data from the gallery or camera. Once the image is received, we send it to the server. The same code is used for the camera function, except for the source type. The signature pad sends the user signature or drawings to the recipients. The procedure is almost the same as sending a photo, except that the image is from a signature pad. We use a third-party signature pad library to capture the user drawings and retrieve the image data from it. This library can be found online with the URL below. It wraps the HTML5 canvas object. Once the script is downloaded, we need to add it to index.html. First, we need to initialize the pad when the draw page is displayed. The HTML code of the draw page is as simple as a canvas with a send button, so we skip it here. When the draw page is displayed, it will check if the pad exists and creates an instance if not, or if it does exist, it clears the pad. When the send button is clicked, we retrieve the image data from the signature pad and send it to the server. Sending text is no more complex than sending an image with just a different message type. We skip that code demo here. Now we deploy the app to iOS emulator using the Cordova command line tool. First, run the Cordova platforms to add iOS as a supported platform. Then run Cordova prepare to deploy the www folder to the iOS project. Open the generated iOS project. Now we open another client in a web browser so that we have two clients to communicate with each other. Log into the app for both the clients. Send a text message directly from the chat page. We can send a photo from the More menu. We can also send a signature. If the recipient is offline, the sender will get an error. In this video, we've extended the demo app with the knowledge we've gained from the previous sections. At this point, you should be able to develop a full PhoneGap application. Check out the actual code if you want the full example. The app still needs a lot of improvement.